All right, so just to get you started on this assignment here, for the first question, Austin rolls a regular six-sided die and a regular six-sided black die. So one's red and one's black. Now, what you could do is, you don't want to think about this in terms of fractions and formulas and stuff. You don't have to. What you want to do is just envision here, the die, right? There's 6 on the red, and here's 6 on the black. Now, the question says that if the red die shows a 4, all right, well, the red die is showing a 4 here, right? In all of these ones right here. 1, 2, 3, 4, 5, 6. Those ones right there. Those are the rolls represented in this diagram where the red die shows a 4. And where the sum of the two dice is greater than 7. Okay, so if we look at that, 6 and 1 is 7 here, right? 5 and 2 is 7. And 4 and 3 is 7. 3 and 4 is 7. And so on, right? 7 and 7. Now it says greater than 7. So we have 8 here, right? 8 here, 8 here. And if you fill this out, and you take a look, and you count all of these ones, these sums right here that are greater than 7, you can just take a look at this and answer these questions. So first of all, are the two events dependent or independent? Well, they would totally be dependent because one of the conditions is rolling a 4, but that 4 also is involved in these sums as well, right? So they're dependent, okay? Yes, dependent. Determine the probability that Austin will win a point. So it's shows a 4 and a sum greater than 7. So if I just blow this up here, if we zoom in a little bit here, right? Of all of these 36 sums, we have 1, 2, 3, right? 3 that would satisfy that problem. So you don't have to do any formulas. You don't have to do anything like that. Now you can use the formulas. You can, and I can show you that as well. But lots of times, if you think about these in terms of diagrams, it's going to be easier. So the probability that he'll win a point here is the probability that you roll a red 4 and a sum greater than 7. So that's these 3. So 3 out of 36. It's 1 out of 12. Okay, so 3 out of 36, which is 1 out of 12. There's your answer there. Okay, so I'll show you the formula here for B2. If anyone cares to see the formula for B, you can look up. If not, you can keep working on your work there. But what we're looking for is the probability of a 4, red 4, and greater than 7 sum. And so if we look at our formulas, that's going to be the probability of a red 4 times the probability of a greater than 7, given that we have a red 4 already. All right, so here's your work with your formula. So the probability of a red 4 is going to be 1, 2, 3, 4, 5, 6. That's 6 out of 36 times, right, out of all of these rolls. And then times, now this one's the tricky one, the probability that we have greater than 7, given that we already have a red 4. And so if we already have a red 4, what that means is we're only considering the red 4 rolls. And what's the probability that we have a sum greater than 7 out of there? Well, there's 1, 2, 3 out of the 6. So that's why you have 3 out of 6 here. So that's 1 out of 6 times 3 out of 6, which is 3 out of 36, or 1/12. That's how you use the formula 2 for B. You can use the diagram, just draw the diagram and work it out, look at those 3 out of 36 and be done. Or you can use your formula here.